Good day, everyone. Welcome once again to our session for today. We are still on our topic, the derivative as a rate of change. For today's lecture, we're going to focus on the application of the derivative as a rate of change to a population change. Okay? So in addition to analyzing velocity, speed, acceleration, and position, we can also use derivatives to analyze various types of populations, including those as diverse as bacteria colonies and cities. We can use a current population together with a growth rate to estimate the size of population in the future. So the population growth rate is the rate of change of a population and consequently can be represented by the derivative of the size of the population. Alright, so we have here a definition. We have if P of T is the number of entities present in a population, then the population growth rate of PT is defined to be P prime of T. Alright, so we have here an example. I think this is already given to you in a PDF form in our use tip. So here's the solution to this problem. So just a quick presentation of the ready-made solution. So we can say that the population of city is tripling every year or every 5 years. Right? So if its current population is 10,000, what will be its approximate population 2 years from now? Okay, so this is the solution, class. Let P of T be the population in thousand or in thousands and T years from now. Thus, we know that P sub 0 equal to 10 or 10,000. So P sub 0 meaning now the current population is 10 or 10,000. And based on the information, we anticipate that 5 years from now, so we have P5, so 5 years from now, the population will be tripled. Okay, so 10 times 3, so that is 30, or 10,000 times 3, this will be 30,000. Now we can estimate the P prime of 0. It means the current growth rate using this expression here or formula, that P prime of 0 approximately equal to the population 5 years from now minus the current population divided by 5, meaning 5 years from now, minus 0, meaning now the time is 0. So you can now you can say that T is equal to 0. So substituting, so P of 5, that is 30 or 30,000, minus P of 0, that is 10 or 10,000. So 30 minus 10 divided by 5 years equal to 4, or this is 4,000. So this is our growth or the current growth rate. So P of 0, P prime of 0. Okay, so by applying equation to P of T, so we can estimate the population 2 years from now by writing P of 2 approximately equal to P of 0 plus 2 times P prime of 0 approximately equal to 10 plus 2 times 4 or 4,000. So we have 18, or this is 18,000. Thus in 2 years the population will be 18,000. Okay, so this formula, class, is taken from, if you can still remember, from our previous lesson. So we have F of A plus H equal to F of A, then plus H times F prime of A. Okay, so still remember this? So we have here the approximate, this is the approximate, right? Now I'm going to show you the solution in terms of geometrical representation or geometric representation of this problem. Okay? So what we are going to do, class, is to use our conventional way of solving the problem by writing first the given. Alright, so from the problem, okay, so we are given here. Okay, so looking at the problem, so let's write down the given. So what are the givens in the problem? So we have the population of a city is tripling every 5 years. The current population is 10,000 or 10,000. So what will be its approximate population 2 years from now? So we have the population now. So population now means the current population is equal to 10,000. And population of a city is tripling every 5 years. So it means that population five years from now is equal to tripling. So it means that the current population is 10,000. So tripling means 3 times the current population. So this will be 30,000. Okay? Now, what is required in the problem? So we are required to find the population population 2 years from now. Okay, so population 2 years from now, or we can represent it as or before that one. So this is our solution. So let's start by letting P of T be the population. So population at T years. So it means at any years, no? T years. So that will be the population at any time T in years. Alright, so to show you the graphical solution of this problem, so that you can relate, what we were talking about before when we speak of rate of change. So that's related to rise over run. Okay, let this be our P of T. So this is the population. And we have here the time in years. So this is okay, so this is the t-axis or time in years axis, and we have here the population axis. So assuming that here at the origin, the intersection between these two axes, So assuming that this is year 2020, so it means now. Okay, then assuming this is our 2021. Okay, and then assuming this is our 2022, and let this be our 2023, and let this be our 2024. So this will be our 2025. Alright, so given in the problem that now means the current population is 10,000. Okay, so assuming that this is at year 2020 now, or the current population, so this is 10,000. Alright? Then it says that population is tripling every 5 years. So it means that in 5 years, so where is this 5 years? Okay, so in 5 years time, alright, so from 2020, so we have 1, 2, 3, 4, 5. So this is 5 years. Okay, this is 5 years. Alright? So in 5 years time, the population is tripling. Okay, so if this is 10,000 here, so this is 20,000 here, then 30,000 here. Okay, so we can estimate that alright, so let this be the point. So we have here initially at t equal to 0. So here, this is our t equal to 0. Alright, and this is our t equal to 5 years. T years, t equal to 0 years. So now, so it means this is now. Okay. Then we are asked to find the population 2 years from now. So 2 years from now means, so where is 2 years from now? So 2 years from now, so it means in 2022. Alright, so this is 2 years. Alright. Okay, so this is just an estimate class. So we don't know exactly where is really the point. So here we have the point, another point. Now we don't know what is the population. So we can estimate, no? If in 5 years it will triple. So from 10,000 it will triple. So we don't know where is the point now. So, but when you speak of population, normally the population has what is the characteristic of the growth of the population? So normally the population has the exponential growth, right? So it will look like that. So we can estimate that our graph will look like this. So where to put that point? So that depends on you, no? We have to estimate. So assuming that we follow this exponential graph for the population, so more or less we can put the point here. But again, that depends on your class. How will you analyze the problem? So, looking at the characteristic of the population growth, so more or less, our graph will look like this. Okay? All right, so this is what we call this is our P sub 0. At this point, the 10,000, this is our P at 0 years. So it means at 2020, we have already this population 10,000. That is our P sub 0 or P of 0, or the value of the function at t equal to 0. That is P sub 0 equal to 10,000. That is the population at t equal to 0. Now this one, so at 2 years, so we have P population. So P population in 2 years. So we have P2. So what is that? This is the P2, meaning the height of this point. The height of this point. All right? And what is this? This is our P sub 5. This is our P, or P of 5. So the population 5 years from now. Okay? So if you look at the graph class, when you speak of rate of change, so now we're talking of growth rate of change. All right? So we will apply the concept on the rise over run. So as mentioned before, so when you connect these 2 points, so we have what we call the secant line. Right? We have this secant line. Okay? Now, if we're going to draw a line parallel to the t-axis, so we have this line. And this P5, okay, so the P5 is the P5, that is the height of the point. So remember in our other videos discussion, so P5 here, that is the height of the point, of this point. So we have P5, and we have here P sub 0. So P sub 0 is the height, from this t-axis towards this point, meaning the height of this point from this axis. So this height is just the same as this one, right? So this is our P sub, or P of 0. This is our P of 5. Okay, so we are now so this is our triangle. Okay, so using this line, since we are just solving for the estimate, so we can use the concept of this rate, rate of change. In this case, we are calculating the estimate of the growth rate of the population. So from the principle, we have rate. Remember from our discussion before, we have rate of change, or the growth rate of change of the population is simply, so using the concept rise over run. So we will still use this concept. So where is our rise and where is our run? So from our triangle, so this is our rise. Alright, so what is our rise equal to? So our rise is equal to, so the height of this, this is referred to the t-axis. So the height of this minus this height. So we have this length or height of this triangle. So that is what we call rise. So our rise is equal to P of 5 minus P of 0. Okay? P of 5 minus P of 0. And we have here the run. Okay, so this is our run. So what is our run, class? So run is equal to, so the length, no, the length of this. So this is, actually we have here this height 5 minus 0, because at t equal to 0, then at t equal to 5, so you just minus 5 minus 0, or simply just look at the illustration. So this is equal to 5. Okay, so the growth rate of the population, or simply rate, is equal to rise over run. So what is our rise? So from the picture, the rise is equal to, we have P of 5 minus P of 0 divided by our run is equal to 5. Substituting, so P of 5, so what is P of 5? So that is the height, no? This is the 30,000. So 30,000 minus P of 0. P of 0, this is our P of 0. That is 10,000 divided by 5. So what is 30,000 minus 10,000 divided by 5? So 30,000 minus 10,000 is 20,000 minus 5. So we have 4,000. Okay, so this is the growth rate of the population. Alright, so we have solved this rate. Now, what is asked in the problem? So population 2 years from now. So let us use the same concept to find the population 2 years from now, because we're just looking at or solving the rate of change, no, of the population in 5 years, in 5 years time. So from this graph, so we are considering this point because this is where our 2 years is located. Okay, so assuming that 2020 now, that is the population 10,000. So in 2022, what will be the population? So it means this one here. So 2 years from now. Okay, so we will consider now this triangle, class. This triangle. So we will consider this triangle. Okay. So again, we have here our rise. So what is now the rise? So considering this triangle, this is our rise. So how to calculate the rise? Or what is rise equal to? So what is the height of this point? So from the t-axis, the height of this point is this one. So we don't know. So that's what we are looking for, right? So we don't know this height. So we don't know this. And that is P2 or P of 2, meaning the population 2 years from now. So we don't know that. How about this? This is, okay, so from here we have this. So this is our P of 0, right? This is our P of 0. This one is our P of 0, that is the height. This is the height, which is 10,000. So our rise is, again, this is the difference. This P of 2, or the value of the population P 2 years from now, minus the population now. So this is the difference. Okay, and this is our rise. Now the run. So where is the run now? So this is our run. So what is our run? So our run is equal to, that is 2 years. Okay, so the distance or the time from 2020 to 2022 is equal to 2 years. Okay, so this is our new run, for the small triangle this is our new run. Okay, so again we'll use this formula here for the rate. So we have rate, so the growth rate of the population is equal to, once again, this is the rise over run. Okay, so our rise now is, we have this height minus this, meaning P of 2, the value of population 2 years from now, minus P of 0, this is the current population or the population now, divided by, okay, so the run, our run is equal to 2 years, or simply 2. And the rate is already known, but before that one, so what we're going to do here is you cross multiply 2 or multiply both sides by 2. So our equation now becomes 2 times the rate, then equal to P of 2 minus P of 0. And we are asked to solve for P of 2. Okay, so solving for P of 2, we're going to transpose this to other side. Okay, so this becomes positive, so you can write that first. So you have P of 0, then plus this one, twice the rate, equal to P of 2. Okay, or rewriting this, okay, so rewriting this, we can write P of 2 first. So we have P of 2, the population 2 years from now, equal to P of 0 plus 2 times the rate of, or the growth rate. So substituting the values, so we have P of 0. P of 0, we know that this is 10,000, right? This is 10,000. P of 0, that is the current population, that is 10,000. So therefore, you have 10,000, then plus twice the rate, 2 times, what is the rate? So the rate, we have calculated the rate that is equal to 4,000. So therefore, we have 2 times 4,000. So P of 2 is equal to, this is 10,000 plus 2 times 4,000, that is 8,000. So this is 18,000. So this is the population 2 years from now. Okay? Alright class, so that is the solution of this problem. So at least now you can relate what we had discussed before about the concept of the rate of change. We have this concept of rise over run for the rate. So now our calculation for the growth rate of the population using that concept rise over run. So at least you have understood how that solution that I had shown you a while ago came up like this. Okay, so this is the solution using graphical representation class. Okay, so I hope you have understood this solution, and I hope that you will be able to apply this when we have our exam. And I hope that if there is a problem that will come up related to this one, I am hoping that you will be able to solve. Okay, thank you very much, and hope to see you again to our last video for this derivative as the rate of change. Have a nice day. Keep safe and healthy always. God bless. Bye.